Unit 2 Chemistry, Chapter 12, Part 2. It's looking at the other properties of water now. So it's very strange in terms of its density. Okay, this of course is a picture of an iceberg with the vast majority of it floating underwater. The reason icebergs or any ice float is because as a solid it is less dense than as a liquid. This is seriously odd. Okay, most things, you cool them down, the vibrations get less and less and less, the particles get closer together, and therefore they get more dense. Water does the opposite. Okay, it kind of starts off getting less dense, but then as it gets down to 4 degrees, it's at its lowest density, and then when we cool it a bit more, it gets less dense. And then as we turn it into ice, it gets even less dense. And then we cool the ice down and that starts to get more dense again. If we look at it, this is water, this is ice. Okay, when water, we've got many hydrogen bonds made, but not all of them. So they can kind of all stumble together. When we make it into ice, every single water molecule has made 4 hydrogen bonds with other ones. So we get this very open structure with holes in it, and nothing can fit into it because nothing's allowed to move anymore. So that's why we get that big decrease in density, and therefore it floats. It's also very strange in terms of the fact that we find water as a solid, a liquid and a gas in the same place at the same time sometimes. And this is because it changes from one type to another very slowly. It also changes temperature very slowly. Now this is very important for things that live in water. It's because it has this high specific heat capacity, which is the amount of energy it takes for it to change temperature, and also these high latent heats of vaporization and fusion. Okay, so latent heat basically means you're putting heat in and the temperature's not changing. Okay, so when we go from ice to water, we put in this much heat energy. So yeah, got your fire under it, but the temperature on your thermometer stays the same. Here, that's your latent heat to change it from a liquid to a gas. So this is latent heat of vaporization. Here is latent heat of fusion. The reason for this is because we've got strong ordered hydrogen bonds. So essentially, this latent heat is not being used to change the temperature, it's being used to break those bonds. Okay, it makes them moving from one state to another slow, but it also means we need more energy. Okay, the heat capacity is the energy that we need to raise the temperature of 1 gram of a substance by 1 degree. Okay, this is water at 4.2. If you compare that to something like ethanol, we need only half as much energy. If you compare it to some metals, we're looking at it being 10 times more for water, for instance, of brine. Okay, so it takes that energy, but it doesn't really change temperature, which means that we are storing heat energy, but it also means that the oceans and lakes and rivers are not constantly changing temperature, which is good news for the fish that live there, because we don't want a rapid change in temperature and them being boiled alive. We also have a very high surface tension. Now this is the energy it takes to break the surface, and the hydrogen bonds are holding that molecule together strongly. So this is a pond skater who actually lives on the surface of water, and you can see that its feet are on the water and it's making dimples in it, but the water and the hydrogen bonds are strong enough that it's not going straight through it.